Arkian Kasikiman Libibi. And today I am here to present example.
So this is the group that we formed, and as shown yesterday that it is indeed a group. So now, if we look at here, so the next slide, we can see that we just switched to make it easier for us to classify the subgroup. This one. So now, let us uh, so in here,
People format of Excel just to make highlighting it easier. So when listing off the subgroups, so we have here the trivial subgroup. So this states only the identity element. In this case are
and another group that we are sure already is the improper subgroup, which is all the elements of the table. So next is finding the table. So if we look at here for the F or for C, we can see that the table is not closed because of this letter. So there is an E, but there in this element, in this group, there is only the element R and F. So this is not a table. So for table so if we look at E and R, we can see that this is closed. So this is already one because as you can see, this is R. E star E produces R, and then the identity element produces E. So if we look at each element, so at each pair of elements maintaining the letter R or maintaining our identity element, we can see that B star B produces E, so it is once again not closed. And R, so R star R, so small letter R produces the big R. And as we can see, this is closed. So this is another subgroup. So we do that for all the two elements to see that we have the sets or the table, which is R, RE, RU, RA, RR, and RY. Next is looking at the four elements. So as you can see here, so I'll just show this. So by listing all the possible 35, so right, here you can see there are some circles here and there. Yep, you can pause the video if you would like to take a closer look. This is table 28. Oh no, that's 25 tables, and here are the rest of the tables, forming the 35 possible tables. So listing all of this produces the result of R Feb, R E U A, and R E R Y. Those are all the possible subgroups along with the improper subgroup. So here's the definition. A subset is a subgroup if, so number one is, the subset is closed under the binary operation of the group. Two, the identity element of the group is in the subset. And three, for all the elements that are in the subset, there is the corresponding inverse. So let us see this. So as we can see, this is still the same operation used and it is closed. So condition one is satisfied. Condition two is there is an identity element. So, sorry. And there is the identity element. So this is checked. Condition 3 is there should be the inverse for the element. So another is satisfied. All three conditions are satisfied. Therefore, the subgroup, the trivial subgroup containing the element R is a subset or a subgroup. So in here, so it is closed. You can see the results are only R and D. And then there is the identity element R. So R star R is E, I R, and R star E is E, as well as E star R. Next is there is a corresponding inverse for each element. Okay. So let's give one more example. And here, so R star R is R. So first, this is closed. So you can see, so R, U, U, R. Next is the identity element. So there is still the identity element R. And finally, there is the inverse for each element. So if we look at the prior subgroup and this subgroup, we can see that as long as the two elements, if each element's inverse is themselves, then all three conditions are immediately satisfied. So we can see the condition three satisfied and condition R because there is always an R there. And finally, this is closed. So condition three is satisfied. Next is R star R. So that is also satisfied all the three groups. Yeah. And lastly, the R star Y. So this is closed. There is the in identity. Then there is the inverse of each element. So that's all for the two element subgroups of my table. Next is the four elements. So if you observe here, so R Feb R, EBRF, BRFE, so all the four elements are the only results, so this is satisfied. Condition one, where this is closed under the same binary operation of the group, is satisfied. Next is R star, R, and other corresponding elements results to themselves. So there is the identity element. And finally, and if we look at each element, so B, the inverse of B is F, the inverse of E is E, and the inverse of F is R. So we can see that each element has an inverse, so that is the condition 3. So next is the condition, so the next table, so REUA, so REWA, and RAU, UY, RE, and, no, this is, should be A. I forgot to change this one. And there, we can see that this is closed. So this is closed. There is the in identity element. Then the inverse of E is E, the inverse of U is U, the inverse of A is A, the inverse of R is R. So all three conditions are satisfied. Finally, here, so we can see that very, rare, rare, and rare. So it is closed. There is the identity element R. Once again, the inverse of E is E. The inverse of big letter R is big letter R. The inverse of small letter R is small letter R. And the inverse of Y is Y. So, as you can see, all the three conditions are satisfied. Therefore, all three or all the trivial or all the subgroups that I stated here are subgroups as well as the improper subgroup which contains all the elements. So for the lattice diagram, I will just showcase in here. Wait a second, I'll find here. Mm, one. So here is the lattice diagram demonstrating it. I'll just so let's just stop sharing so that only my screen can be seen. And here, yeah, in here is, as you can see, so this is the improper subgroup. Under the improper subgroup, there is the RFEB, RERY, and then REUA. Then under the REUA, there is the R and U, and then R and A. And then under all these three lattice diagrams are the R star E, or RE, the set of RE. And here, under the RERY, there is the subset of RY and RR. And finally, in the last one, there is the trivial subgroup. So this is the subgroup or the lattice diagram containing the subgroup. That is all. Thank you for listening for this video activity presenting the subgroups that were formed from the set. I'll end this. So once again, this is Mark G and Abel Domaro from BSED Math 3B.